And in both cases, or whenever we look at the actual value or the type of the value, it is going to return undefined. So the value of A, because we've not set it to any value, is undefined, and the type of A is undefined. All right, but here that's just a variable. We didn't set it to a primitive string number or Boolean or anything of the sort. All right, let's suppose that you actually are expecting the variable to hold a reference to an object. So just to kind of copy a quick example from a previous lesson, let me comment all this out and paste in this. So here we have our regular expression example where we're going to try and match a pattern XYZ. And we're going to use the strings match method, passing in the regular expression, literal, that we created in line 5. But this time there is no match. There is no string XYZ in my value variable. So what is result set to? Well, let's see what we get. In this case, we get result is set to null. All right. Well, what is the type of results? Type of result. All right. This is going to require a little bit of explanation, okay? That's the quirk with null. It will actually return object, not the primitive type null. And that's a known bug in JavaScript that will likely never be fixed because too much code on the internet depends on the fact that type of null equals object is, you know, it's basically baked in and grandfathered at this point. But by all rights, if JavaScript had been designed correctly from the start, that would be null. But hopefully you get the idea there. All right. But the interesting thing about getting a null result when we expected an object back is that we can do something like this, and I'll just copy and paste this instead of typing it all in. We can check result and say, are you, you know, and we'll do the strict equality evaluation. Is result null? And if it is, then we can say, well, no match was found. XYZ was not found in our value. All right. And so this can be extremely helpful whenever we're building our applications. All right. So just to kind of recap, null, the primitive data type null, is not 0. It's not undefined. It's not an empty string. It simply means that you have a variable where an object reference was expected, but it's not set to any object reference. It's different than undefined, right? Because undefined says I'm expecting to have a value, but one was never set, and it was expecting maybe a number string or Boolean. No. We're expecting an object reference, but we don't have an object reference at this time set to our variable. Okay, so hopefully that makes sense. And let's continue on. See you there. Thanks. It's been quite a few lessons now since we've talked about the built-in native functions that return objects. We saw at that time that there was a date constructor function, and that date constructor function will return an object that allows us to work with dates. And so I just wanted to take a brief look at what it can do and how you can actually work with date type information using the date object. So let's start off with a very simple case here. I'm going to say, hey, let today equals new date, and that will by default give us right now, this date and time. All right. So what I can actually do is actually initialize that date object with a specific date using one of several different formats. So I may want to create a date that represents my birthday. So I'm going to create a new date and I'm going to pass in. And this is interesting, right? Because if I look at IntelliSense, it has an up and down arrow. I can actually use the arrows on my keyboard and it will show me the various versions of constructors that are available with which to initialize this date object. So we can start off with something really simple and just kind of a full date, like December 7, 1969. And we'll give it a time even at 7:01:23, just guessing at the actual minute and second of my birth. I don't really know exactly. I know it was early in the morning, that's all. So that's one way to initialize the date, but there's a couple of other ways. Let's just do like let Bob equals new date. And there's a file system date type that looks something like 1969-12 for the month -07, and then T for time, and then 07 because it's, you know, on a 24-hour schedule, :01:23, and that's roughly about the same. These two will create the same basic time. All right. There's also, we could just kind of simplify things a little bit here using a different format. Just give it the year, month, base 0, and day, I think base 0 as well, though I'm not really entirely sure about that. And then let Bob equals new date. It's kind of the same thing. 11/6, and then 7:1. 7:1:23. So I think these are about the same. I may be off by one. I forget if it's 0 based or 1 based, but you can look that up fairly easily. I'm not going to use these, but I just want to show you that they exist. Okay, but we have here now today's date and my original date, my birth date. And so what we can do is something interesting, like get the time that's elapsed between those two dates by just saying var elapsed time equals n equals today minus Bob console.log elapsed time, and what it will give back to me is the number of milliseconds, all right, between those two dates. So this is the number of milliseconds, and then I could divide it out, calculate the years, the months, the days, the hours, minutes, and seconds if I wanted to. All right. So that's one thing that I can do, is determine the elapsed milliseconds between two dates. You can also get parts of a given date. So I can go console.log bob.getDate, and it returns 7. What does that represent? That represents the day of the week. So in this case, Monday would equal 1, and Sunday would equal 7, which seems a little backwards to me, but hey, that's what you get when you create a language and you set null equal to object and other kind of quirks like that. Moving on, console.log bob.getTime, and this will be represented the time of day in our date object. And so that was the number of milliseconds. And so that's a little bit less useful, but you can do other things. And let me just paste in a bunch of these all in one shot. You can get the month, the day, hours, minutes, seconds, and milliseconds. And then there are also some additional date functions for things like conversion to UTC or Universal Time Code, and local dates and times. So converting back and forth between UTC and local date time. And that's pretty much what you can do with the date object. And so let's continue on in the next video. Thanks. Previously, when learning about built-in natives, I explained how the string primitive is mapped to the string built-in native object, and by boxing the string primitive into its equivalent string native object, built-in string native object. JavaScript therefore will supply us with a rich set of functions. Now in this lesson, I want to demonstrate just a handful of these very useful string methods that are supplied to us by the string built-in native object and explain why they're useful. And I'm just going to pick the ones that I think are useful, to, at least they've been useful to me in the past, but there's a bunch more, and I would just recommend that you use Bing or your favorite search engine to search for JavaScript methods of string, and you might find the Mozilla developer site, and it will give you a full listing of all the methods that you can get on that string object. All right, so first of all, we're going to need a few strings to work with just for fun. And so I'm going to create some different ones here. Two are quotes. So the first quote is knowledge is power, but enthusiasm pulls the switch. And second is a famous quote from a good friend of ours, do or do not, there is no try. And then finally, a listing of random numbers that mean absolutely nothing. And then, you know, one of the things that I didn't really mention at the time is that, do you realize that, and I'll just put this here, you can even call these methods on string literals. Like, for example, console.log, Bob loves you, dot. Isn't that crazy that you can just do dot on a string literal and call to uppercase? Well, you certainly can. So let's see this message in all of its glory, because I do in fact, whoa, let's call strings. I do in fact love you. All right, let's move on. All right, so let's use a couple of interesting methods of string. So we're going to use the split method. I'm just going to call set my split equal to this third one defined on line 3 with those with those values, those numbers that are separated by commas. And the split method will allow you to say, hey, every time you see a comma, split that up and take the element in between the commas and add that to an element of a new array. And so let's go console.log my split. And here we have an array with each value as a separate member of, or separate element of that array. Pretty cool. So you'll do this a lot whenever you're working with data and it comes to you in some sort of string-like format. You can split it out. All right, next up, we can slice a string. So let's go let my slice equal first.slice. And then we give it the starting index and the ending index just to kind of pull out one little piece of the string and put it into its own variable. So then we can do a console.log my slice. So this first sentence we would count, you know, to the position 13 and then to position 18, and hopefully we'll grab out that word. And we grab out power. Same basic idea with the next one, which is substring. It's just a tiny bit different. So let my substr equals first.substring. And here we'll start with that same index, but we'll say just instead of giving you the end position, just go over five positions. So this is the start, and then this is the length that we want to pull from that first string. And so then we'll go console.log my substr, and we get the same value there. Okay, similar ideas between slice and substring. Moving on, we want to return true or false if our string ends with a given string to compare it with. So my ends with equals, and we'll use that second string that I created here, try or do or do not, there is no try. And we'll say, hey, does that string ends with true or false the word try, period. And then we'll go console.log my ends with true. Great. And hey, well, then we can do sort of the same thing. let my starts with equal second dot starts with. And so this is just a way for me to say, hey, is this the string I was expecting? Does it have the values in it that I want? So I can say, does it end with this? Does it begin with this? True or false? All right, so that's true as well. And then we can even say, hey, you know, someplace in the string, does it include the substring or the string there? So is the word there used in that second string? Console.log, whoops, my include whoops, there is no there, all right? How about capital T in there? That's true, all right? So it is case sensitive. All right, so let's comment all of these out, which is interesting. Now, let's say let my repeat equals ha exclamation mark space dot repeat, and the number of times I want that repeated is 3, and then let's do a console.log my repeat, and I get ha ha ha. So the repeat method will repeat whatever the string is the number of times you tell it to, and then we save that off and do its own variable. And I think the last one we're going to look at is a way to kind of clean up a string. So let my trim equals, and I'm going to put a bunch of spaces here, and then in between I'm going to say this is bloated, right? And I want to clean it up a little bit. So I'm going to go console.log, and the first time through I'm just going to say trim.length. This will give me the total number of characters in that string, but then the second time I'm going to do what's called chaining, method chaining. So my trim dot, I'm going to use the trim method. That should clean off all the empty spaces at the very beginning and the very end of my string. And then I'm going to grab the length property. So you can see dot trim, dot length. I'm able to, since trim will return a string, then I can call the next method or property on the string because I'm working again with the string type. So I'm chaining those calls together to get the result, essentially the before and after. So before I call trim, we're looking at 16 total characters here. But when I call the trim and I get the length, there's only 7 characters. That means the word bloated should only be 7 characters long, and it is. All right. So those are some helpful string methods on the built-in native string function, constructor function. And we'll do the same thing for array in the next video. We'll see you there. Thanks. Since we gave strings methods the proper treatment, I want to do the same for arrays. So we'll do that here. And let me create a couple of arrays. Here I've got an array called names and an array called others. I've got an array called lost and an array called Fibonacci. So the obvious difference is that here I'm working with strings, here I'm working with numbers. All right, so we're looking at methods that can be applied to arrays, right? So the first thing we can do is combine 2 arrays together. So we can use the concat method. So here I'm going to take the lost numbers and I'm going to concat them to the Fibonacci numbers, giving me a combined set of array values. And here I'm going to go node array-methods, the name of the file I created. And I get a long set, a complete set, where you can kind of see the division between the 2 sets. Now they're all in one array. Okay. Seems like it might be helpful at some point. Otherwise, we'd have to loop through and push or pop, or I mean push elements of one array into the other array. That might be a little bit of a cumbersome process. You can also do something interesting like console.log, and we can take combined, or the combine. Well, we don't need that. We can use Fibonacci. And what we'll do is call join. And I can say, hey, join all the elements of the array together and separate them with this string. So I'm just going to use like a tilde here for no other reason than the fact that we just haven't used the tilde yet. And I think now we've used every character on the keyboard at least once. All right, so let's save that and then run it. All right, and you can see that I just merely printed out the Fibonacci numbers with a tilde. Join them together into a single string, but they're separated by a tilde now. Okay. We've already talked about or demonstrated push and pop. I don't want to go back into those, but they're essentially ways to add elements to the array or remove the last element from the array. There's some other ways to do that too. For example, here we've got a console.log. We'll take the loss numbers and we'll call the shift method. And what the shift method will do is take one item off the front side of the array and it'll return it back to us to print out. But then if we go and look at the array, we'll see that it actually removed it. So it's essentially a pop, but instead of working off the back end, it works on the front end. Okay, so let's see that in action. And we get that exact behavior that I described. Great. We can do something called an unshift, which is to add items to the front. So it's essentially just like a push, except we're going to add items to the front, one or more items. So here we go with the lost unshift, and then we're going to say, hey, let's add we can add one, we can add two, we can add a bunch of items, right? And so now when we do console.log lost numbers, whoops, we'll see, whoops, what did I mess up? I call it list instead of lost. There we go. And so now I've added the values 1, 2, 3, and 4 as new elements of my array, and then it continues on with 8, 15, 16, 23, and 42. Okay. Let's comment all these out. Moving on. Let's find an element, or first of all, here, console.log. Let's take the names and reverse their order. So first of all, we'll start with the original order, and then we'll tell it to reverse, and we'll print that out. So originally David, Eddie, Alex, Michael, but then we get Michael, Alex, Eddie, David. All right. Furthermore, what we can do is go console.log names.sort. It's a sort method. I got to use the method invocation operator. So now when I run it, we get the alphabetical order: Alex, David, Eddie, Michael. All right. Next up, let's see how you can identify where a given element is in an array by looking up its value using an index of method. So here we're going to go console.log, and we'll go others.index of, and I'm going to look up the element named Mark. All right. And so let's see where it's at. It should be the third element of the array. So I'm going to go back up here to others, 0, 1, 2, 3. It's at the third element, so then I can go grab it. Okay. How about we look at and find the last index of, and let's take those combined numbers. Remember all those numbers, we basically put them together. let's go the last index of the value 1. So here, first of all, let's do this, just so we can easily see what the current value of combined is, and then we'll say, hey, we're going to search for the last time the value 1 appears in my list. Which array the element is it at? All right. Whoops, what did I do this time? I think it's just combine, right? Still not right. Ah, because I commented it out. Now let's try it. There we go. All right, so you can see that our combine variable holds 4, 8, 15, 16, 23, 42, 1, 1, 2, 3. So now I want to see what element is the last, and it says it's at the 7th element. So 0, 1, 2, 3, 4, 5, 6, 7. 0 based. So the last index of 1 would be at 7. So it's useful if I'm looking through a large set of data and I want to find the last instance of a given value. I can use last index of instead of index of, which will give me the first index. Okay. All right, moving on. Previously we looked at the map function of an array. I don't want to belabor that because we've already seen it. But we can do other interesting things too, like we can create a filtered list. So using arrow functions. So var filtered equals, and we'll go with combine dot filter, and now I'm going to give it an arrow function. So for every number, I'll just say it's x. I can give it any input parameter name. So here's the body of my little arrow function. If x is less than or equal to 15, then I want to return x. All right? And effectively what will happen is it'll return only those numbers that match this expression, so that when I do console.log filtered, I should only see numbers that are less than or equal to 15, and so I get a filtered version of that combine array. Pretty cool, and a good example of why you would want to use arrow functions. Similarly, you can do something using a what's called an iterable. It's a method called for each. So this will go through each element of an array, and inside of that I can then create an arrow function similar to things we've done in the past. Right, where I'm actually just going to, for each element of the array, go ahead and console.log this string and interpolate in the name that's passed in. Pretty cool. And then we can also do some checks. So for example, I can say, hey, can you tell me if every one of the values inside of my array match a certain condition? So here I would go console.log, and I'm going to take that filtered list that I just created here. So this should contain all of the values that are less than 15 from my combine. And here I'm just going to say, hey, let's go with filtered. Is every one of those values, and here's where I'm going to create an arrow function. So let's call this num. Are every one of those numbers less than 10? True or false? False. Why is that? Well, I happen to know that there's at least a 15 in there. Maybe if we increase the number to something like 16, are all the numbers less than 16? Well, they better be, because they wouldn't have matched this criteria, right? True. Okay. So that's the every method of an array. Similarly, we can look at sum. So tell me if at least one element of the array matches a condition. So here again, console.log, start with that. Let's create an arrow function. Whoops. We'll start off with, use the Fibonacci numbers. So sum, true or false? Well, let's start off here with an arrow function, number. Are all the nums greater than 50? True or false? True. Okay. Are they all greater than 100? Or are there any of them? There's at least one item greater than 100. That's what we're testing for here. False. There's no items in that Fibonacci sequence that we have here in our array that are greater than 100. All right. So hopefully, first of all, you can see that there are some very useful helper methods on the array built-in native. Secondly, more examples of arrow functions that are used inside of some of these methods. Hopefully that's useful. Let's keep going. See you in the next video. Thanks. You have to try really hard to force JavaScript's compiler to throw an exception with the code that you write, unless you simply just typed in the code incorrectly. Now, I suppose some might consider the fact that JavaScript tries so hard to work with whatever crazy code you offer it as a positive thing, but personally, I wish that JavaScript's compiler would throw errors more often. I mean, you should never be able to do something as absurd as what I'm about to do here. Let me paste in a little code. I mean, this makes absolutely no sense. Here we're going to attempt to multiply 7 times undefined divided by Panama. Okay, what's the answer to that? Well, you know, it looks at it and says, well, I'm not really sure that that's going to come out to be a number, so I'm just going to return not a number. And we can check for that, not a number, and, you know, I guess we can account for that in our logic of our application, but kind of wish it would just throw an exception, but I guess that's not the way that JavaScript is made to work. I suppose it tries to do whatever it can because it, I guess, figures that perhaps people come from many different programming backgrounds, or that since it's a dynamic language, maybe it should be able to accommodate any of these crazy situations. But when JavaScript does encounter finally something that it cannot work with, we call that an error. We call that sometimes an exception, an exceptional situation, an exception, something it just can't work with. And the JavaScript runtime will simply quit at that point, throw up its hands and say, I can't do anything with this line of code. And if I can't do anything with this line of code, that means I can't do anything with any other lines of code. I quit. So it's when it does actually reach an exception, it completely bails out on any additional code that you might have written. All right. So when this happens and you can identify where in code these issues are likely to occur, you can and should build some safeguards to ensure that they never happen again. Like in this case, we might write several lines of code prior to attempting line number 1. We might do things like to ensure that if, for example, these values were contained in variables, we might try to make sure the variable was not undefined. We would try to make sure that the variable had a data type of number and not string or something else, right? So that we could do that calculation and expect a real number to be assigned to the variable A. Oh, if we were working with objects, we might want to make sure that the property actually existed on the object that was passed into our function. And so we would look and say, do you have a property with this name? Does it have a value? Okay, we can work with that. And so there are some safeguards that you can kind of build around your code to bolster it, to make it more resilient to the possibility that its inputs were bad and that it ultimately might throw or raise an exception. So other times, these things might be completely out of your control. You still need to write your code in a defensive manner. So for example, you might want to request data, maybe JSON data, from a web server that hosts a web API. And depending on what you're requesting and depending on whether the web server is functioning correctly in that moment, you may or may not receive the data that you're expecting. So this might cause your code to throw an exception. Well, here's another case where you should be able to kind of code defensively, account for the possibility that an exception could occur, because calling into another resource across the world is a highly risky proposition, and it could result in an exception. So an exception and an error, I use those terms kind of interchangeably. In my mind, they're the same thing. But whenever a problem arises, an exception is raised by JavaScript in some way, the information about that exception is boxed into one of these built-in natives that we learned about several videos ago that were created in the exception, capital E, exception function. And it will give you an opportunity to inspect that exception or that error object and look at, for example, the error message and be able to handle it gracefully, and we'll talk about that in this lesson. How you can safeguard your code. The code that you suspect or that you know would be prone to throwing exceptions, and you can do that by wrapping it in a construct in JavaScript called try-catch. So here, let me comment this out, and then I'm going to create some examples. Let's create one where I know I can create an exception. So here I'm going to create a function called before try-catch. So here we're just going to create one and not attempt to catch any issues that might be created. Now, here I'm going to just say let this variable obj equal to undefined. And I'm going to act like obj is an object. So I'm going to just act like it should have a property on it. So I'm going to do console.log obj.b, all right? And I know that this obj does not have a property b. That should trigger an exception in JavaScript. It's one of the few cases where we can actually force it to happen. So if that happens correctly, as I suppose, then you should never be able to execute this line. So if the previous line of code throws an exception, you'll never see this, all right? And just want to point this out here. I'm going to have to escape this in my literal string, this single quote in the contraction YUL, because JavaScript, and in this case, Visual Studio Code, doesn't recognize it as an apostrophe. It recognizes it as the closing single quote for my literal string. So to escape that character and treat it like I mean to treat it, as an apostrophe, I'll use a backslash right in front of it. So now that little combination of characters will treat it as an escaped apostrophe instead of the closing single quote. All right, but at any rate, just an aside there. Line 7 should never get executed because I am expecting line number 6 to essentially throw an exception. So here's what we'll do. We'll just call before try catch, and we'll execute that. And you can see that cannot read property B of undefined. Perfect. All right. Now let's introduce a different function called after try catch to kind of show you how this works. I'm going to comment out the call to before try catch. Here, let's just grab all this and copy it all. But I'm going to first of all create a try. And I'm going to go ahead and just hit enter on my keyboard. I'm going to use the arrow keys to create a try-catch statement. All right, see that? And inside of the try, I'm going to attempt to perform these 3 lines of code. Now, I don't have high hopes for 17 ever running. However, I suspect that what I can do is do something like this if we were to reach an exception in line number 16, which we will. So in this case, what I can do is say I caught an exception. that was thrown by the JavaScript compiler. And I can even inspect that error object, and I know that it has a message property. So we'll do something like that. But the key here is that this will not break my application. My application can continue to execute. So I can go console.log. My application is still running. So even if we encounter an exception like I suspect we will in line number 16, we can catch the exception, handle it, do something, and then move on. So let's start with this, then we can move on and see if there's other things we can do here. Whoops, what am I doing wrong here? Oh, I need to actually now call my after try catch. So now let's try to run it. All right, I caught an exception, cannot read B, property B of undefined, but my application is still running. So it did not completely just shut down my application. Perfect. Now, what I can do is actually add another statement called finally. And this will run regardless of whether my try makes it successfully all the way through or whether the catch has been invoked. So I can just do console.log. This will happen no matter what. All right. And usually use a finally statement to clean up any resources that you no longer need. I'm not sure how useful that is in JavaScript personally, but you might find a use for it. All right. And so you can see that we have hit the catch, but then it also executed the finally statement before continuing on with the remainder of the application. So there's a pretty effective software development strategy of throwing custom exceptions from your functions with the intent that those exceptions are caught by the caller. So it's a form of communication. If it succeeds, then it should succeed quietly. But if it fails, your function would then throw an exception that would be handled by the caller, and it can decide what to do next. So I'm going to comment everything we've done so far out. And we're going to create one more example here. So let's do that. And I'll comment all this out too. And let's go here. Okay, so this time, let's go function, perform calculation. And this calculation will take and look at a object that will pass in. And we're going to say, hey, if that object obj dot has own property B, wait, if it doesn't have its own property. So I could do equals false like that, or I can do a shorthand version of this by just using the exclamation mark right before the expression. See that? That exclamation mark? It kind of makes it the negative. So if has own property returns false, then the entire expression will be true. This is if not has own property equal true, essentially. Then what we can do is actually throw a new error. All right. So here we'll just describe or give it the message we want to tell what the problem is. Object missing property. All right. Otherwise, if that turns out to be a truth that the object does have its own property, then we can continue with the calculation, and I might just return, the value 6 or something like that. Okay, whatever the calculation using obj dot property B. All right. So here we go. Now we're going to call into that function, perform higher level function operation. And here let's do let obj let that value equals 0. All right. And then let's do a try around value equals perform calculation. And I'm passing in an object that's undefined, right? Because I didn't set it to anything in line 41. So I know it's going to throw an exception. Here, I'm going to catch it. I know it's going to come back to me as a boxed built-in native error, and print that out. And what I can do then is kind of to show how this would work is if, you know, value is equal to 0, I know that the perform calculation didn't work, so I can run my contingency. Perhaps I can do some retry logic. You know, whatever I need to do to make my application handle this exception gracefully, and then continue with whatever logic makes sense after that. So let's see if this works. I think I got this right. Let's call perform higher level operation, and I'm not sure what to expect to see here, but I don't want to see any exceptions pop up, other than the one that I'm printing out and throwing here. So let's try that. All right. I think in this case, I'm going to need to do this. Let's see if that works. All right, try that again. All right, that worked perfectly. Okay. So in this case, created an object, passed it in, doesn't have the property B, so we throw an error. Remember, this is a strategy for us to do some checking and then look to make sure that if an exception happens, we can handle it. If not, we grab the value back. But if the value is 0, then perhaps we need to, we hit an exception. Maybe there's some other flag we can use to see whether we're getting the value we thought. Perhaps in the catch we can do some work. Maybe in the finally statement it makes more sense to put it there. But at any rate, we can gracefully recover from the exception being thrown, because that's kind of just our strategy that, hey, this function does not have what it needs. So you're calling into it, but you didn't give us what we needed. So you're going to have to write some logic to figure out what to do next. All right, that's all I'm trying to say there. So this is a good start to help you understand that you do have options when you think about how to safeguard your application against potential exceptions that could occur and shut down your code completely. Ideally, you could think of all the ways that your code could possibly fail and attempt to mitigate those potential issues up front. But after you've done a reasonable amount of work to perform gated checks like I demonstrated here in line number 33, 34, and 35, then you can ultimately wrap your code in a try-catch statement, try-catch finally, whatever works for you. And furthermore, you can throw custom errors from one function to another as a means of communicating failure and allowing the caller to implement some contingency like we looked at in line number 50 there. Maybe even some retry logic to ensure that ultimately the application is performing correctly and it can recover from any exceptional situations. All right, that's all we really wanted to say. All right, so we're doing great. Almost done. We'll see you in the next video. Thanks. Up to now, I have avoided talking about JavaScript in the specific context of a web browser. I actually re-recorded this entire course from scratch earlier this month because I started talking about JavaScript in a web browser from like the very first video, and it became obvious that I spent so much time fiddling with the HTML, explaining the DOM, and ultimately I was struggling to get just to talk about JavaScript by itself, and so that's why I took a different tact and re-recorded this. So this time around, as you know, I started with pure unadulterated JavaScript, and now here at the very end of this course, I'm talking about JavaScript and how it's used in a web browser, which there are some peculiarities that I wanted to talk about. And I hope the approach makes sense. I hope that this approach worked for you, and even if this isn't how you wanted to learn JavaScript, I hope you can understand and see the rationale behind it. All right, enough of the pretense. As we start dipping our toe into JavaScript in the web browser, I want to talk about the amazing work of a web browser and how it will actually turn a request by just typing in an address into the point where we're actually viewing a page on screen. I want to talk about how it begins to understand the HTML that it has downloaded, as well as other files like CSS and JavaScript files. And I want to talk about all the things that it has to consider before ultimately rendering a web page out to the end user to see. It's really quite amazing. So let's start at the very beginning. I don't want to talk about all the process of requesting and resolving to an IP address and all that. Let's just speak in very broad terms. There's a request made from the web browser to a server, and ultimately an HTML file will be downloaded, or I should say a collection of HTML is downloaded to the web browser. And then there are references to other resources like CSS files and JavaScript files and things that begin to be downloaded as well. Kind of all this happens really at the same time, along with everything else I'm going to talk about here. And this isn't really intended to be deeply technical. I'm really just going to paraphrase the general order of events because I'm not really privy to what goes on inside of a web browser. I haven't really looked at the source code. But at any rate, while it's downloading all the resources, it has its HTML. Now it's grabbing its CSS. Now it's grabbing its JavaScript. And it's working asynchronously in the meantime with what it does have in hand, in memory, as it's continuing to grab these resources down. Well, while that's going on, the browser is beginning to construct this object-based representation of the HTML elements in the HTML page, and it constructs them into a series of objects that are called nodes. So it'll create a node for a given paragraph, a node for the ID of that paragraph, a node for the class of that class attribute of that paragraph, a node for the text that belongs to that paragraph. You can see where I'm going with this. Everything gets its own little instance of an object, and ultimately it's building this object graph that represents all of these elements, their attributes, and their values, the text values. And so each element node could contain other element nodes as well. So a paragraph could conceivably have some div tags, or probably more likely vice versa. A div tag has a paragraph, a div tag has a header, has an unordered list, which has list items, and so on. All right, so there's just that nature of HTML, and the object model that's being constructed in memory has to consider all those kinds of relationships, as well as the attributes and the text values of each of those attributes. So at any rate, the final result of all of that work is this rich object model that represents the document that can also be accessed programmatically. We'll talk about that in just a little bit. But at some point, the browser considers then all the styles that it has downloaded, whether embedded in the HTML page itself or through one or more CSS files that have been downloaded as well. And it also has to consider any of the default styles for elements. So these are ones that are baked right into the web browser. It starts to decide which styles will overwrite the other styles, which values will overwrite the other values. And so now it has to then start to apply those styles to the various nodes inside of this large object graph of node objects. And once it's kind of settled on which styles to apply to each of the individual nodes, it then has to calculate how much space each of those will take up on the web page, all right? So that it can essentially at some point visually render those onto the web page for the end user to view. The next thing that it's going to do is it's going to start to parse through the JavaScript that it's been downloading from various files, and it'll determine what needs to happen and when it needs to happen. So some code can be executed immediately. Some code is attached to the various events of the various nodes in this object graph of nodes that represent the web document. And we're going to see this in a little bit. It'll impact how we write our code and where we write it in the HTML document. So when we're talking about this collection of nodes from a programmatic standpoint, as well as the entire API of the methods and properties that we can access programmatically to change things about the nodes that represent our document, to modify them, to add new nodes, to remove nodes, things of that nature, as well as the web browser as a whole and all of the functionality that it provides to us, like the ability to manipulate things like the history, the console window, and any of the other debugging windows that might be available. Take all of that into consideration, and that is at essence something called the document object model, or the DOM. All right. And so we'll talk about the DOM in the remainder of this video, in the next couple of videos. But eventually, after it's taken all those things into consideration, then it finally will render the page visually to the end user. But its work is not done at that point. Now it's listening for the user's interaction with the various nodes inside of the document. And when the user interacts, it might click or hover or mouse up, mouse down. It might use a keyboard. You know, the user can interact with the various elements on the page in various ways. And if the software developer or the web developer has attached event handlers, functions that should be called in response to those interactions, those events, then the web browser has to say, oh yeah, we have these two functions that we're going to call because the user clicked on this button. Go ahead and execute those two functions now. All right, so when we create those associations, HTML actually gives us a couple of ways to create those associations, but we're going to look at some programmatic only ways to create those associations. We'll talk about that in the next video. But at any rate, as developers, we can also interact with other APIs that are exposed to us. For example, most web browsers expose the console window so that we can write little error messages out like we've been doing up to this point. So we're primarily interested in the document object model as JavaScript developers. Again, it contains an object graph that represents every element, the attributes of those elements, the text that might be associated with those elements, and the relationship between two elements. You know, one might contain the other, or they might be siblings, and so on. Each of these objects are referred to as nodes, as I said earlier. And I just want to make the point really quick that when we're talking about nodes inside of the document object model, that shouldn't be confused with Node.js, the environment that we've been using up to this point to execute our various little JavaScript examples. They're completely different. They have no relationship to each other. All right. So at the highest level, you have the document node, and the document node will contain one or more element nodes, and each of those could contain other element nodes, but each element node will probably have some attribute nodes associated with it, and maybe a text node associated with it. Okay. So the DOM also includes a rich API. So lots of functions that we can call in order to access the various nodes, their attributes, the text, and so on. All right. So we can find a specific node or a collection of nodes that match our criteria. And then once we have a programmatic handle to a given node or multiple nodes, then the API also gives us some functions that we can use to modify the values of those nodes. Everything from changing the text of a node to changing the attributes of the node, like changing the class that is associated with that given node. We can remove nodes, we can add nodes, all that programmatically. The API also allows us, as I mentioned a little bit ago, to associate events that are raised by the web browser, usually because the end user triggered the event with a mouse over, a click, whatever the case might be. As developers, we can associate our functions with those events. And then finally, the API provides some helper functions to perform various things. One that comes to mind is network operations, like being able to call out to another web server to grab data or to grab some other code that can be executed. But finally, there are several ways that we're going to talk about in this video to basically write your JavaScript in a web page, or associate your JavaScript with a web page. And if you have professional aspirations, then you should be aware that not all of these techniques are smiled upon. In fact, most of them are frowned upon. There's one that's not. So you might see some examples, and here we'll just add this to our existing page here that I just created randomly in dom-intro.html. And I'm going to create a button, and in that button I'm going to say click me, and then here I'm going to add an on-click equal. And I believe we've done this already, right? But I'm just going to write some JavaScript right here. Now, using this technique, I'm able to pop up a box, an alert box in the browser to just kind of execute one little simple line of code. So let me see how I'm going to do this. Let's right click on this.